because there are two comparison tests for series, and the first one is called the comparison test, singular. So, two comparison tests, and here's the first one. So I'll read it and then I'll write it with you all. So the comparison test. For these comparison tests, you have to have two series. One of them is the one they are asking about. The other one is one that you know about, like a geometric series that you know what happens, or your best friend P series that you know what happens. So for the comparison test, singular, because there are two of them. Let me write that. There are two comparison tests. And the first one is called the comparison test. So the first one is you have two series and they have positive terms. So we have this. Suppose we have series A sub n and series B sub n. So A sub n is a sequence of positive terms, and B sub n is another sequence of positive terms. And of course, with the series, we are adding the terms of these sequences. So these are series with positive terms. And they did not write this in the book, but you know what happens to one of these guys. You know if one of them that you've picked out of your toolbox, you know whether it converges or diverges. So I'm gonna put that here in parentheses. Maybe I should have written it as a note, but you know what happens with one of these series. And in the write-up of the comparison test, they're assuming you know what happens with B sub n. So you know what happens with one of these series, like you know whether or not series B sub n converges or diverges. Because it's one you pulled out of your toolbox, like it's a P series or it's a geometric series and you know the value of R. So you would know what happens with it. So then we have this. There are two parts. Number one, if series B sub n is convergent, and term for term of the sequence A sub n is less than or equal to sequence B sub n for all n, then series A sub n is also convergent. And while they state it for all n, it could be for n eventually. Like maybe it doesn't happen, maybe this inequality doesn't hold for the first 10 terms, but from the 11th term on, this inequality holds. From the 11th term all the way to infinity, well, that's okay. Although they say for all n, it's okay if there's a finite number of terms for which it's not true. Now, the second part is this. If series B sub n is divergent and term for term, again they said for all n, but A sub n is greater than or equal to B sub n for all n, then series A sub n is also divergent. Now, if these inequalities do not hold, you have to use a different test.
Both of them you have or equal to.
Do I have what for both of them?
Between the two, you have less than or equal to or greater.
I have less than or equal to and greater than or equal to.
What if they're equal to each other?
Oh, if they're equal to each other, I guess then whatever happens to B sub n happens to A sub n. They'll be the same series, yes.